Hello, welcome along to another lesson with Mr. Burns. In this lesson we are going to find the equation of a straight line which is parallel to another straight line. And we'll be given that point in which that line passes through. So this question says, find the equation of a straight line which is parallel to the line with the equation 3y is equal to 4x plus 9 and passing through negative 2, 4. Okay, so we're trying to find this straight line, okay, which passes through negative 2, 4 and is parallel to this straight line, okay, and this black one is equal to 3y is equal to 4x plus 9. So these ones are parallel. That means they're equidistant from each other, which means their gradients are exactly the same. Okay, they have the same steepness. Okay, so I've just drew a sketch of that there. It might be going down from left to right, it might be horizontal, it might be vertical. Okay, just a wee sketch to show you that. Now, our structure for finding the equation of a straight line, you have to have a point on that line. We have that point. Do we have the gradient? Okay, so your strategies for the gradient, 2 points. Don't have that. A diagram, vertical over horizontal, don't have that either. Can we extract a gradient from an equation? Well, we have an equation here, right, which is this black one, and we're trying to find this blue one which is parallel to it. What's the gradient of this line? Is it 4? To extract a gradient, they need to be in this form. Y equals mx plus c. So what do we have to do with that? Divide each term by 3. Dividing that by 3. We get 1y. Don't need to write the 1. Dividing that by 3. So 4 divided by 3 is 4/3. And dividing 9 by 3 we get 3. Okay. Now the gradient of that black line is 4/3. The gradient of the blue line is exactly the same. Okay, so we would say that we can't just use that gradient. We would have to say, therefore, let's call that M1. M2 is equal to 4/3. Since M1 is equal to M2, right, for parallel lines. Now the more communicating you do, right, the increase the chance you'll get in getting all the marks. Okay, now you can do an abbreviation for parallel. We can do that there, alright. So a lot to do there, right, but this your thinking step, this is your communicating that it's the same, and the knowledge that you know that the gradients are the same. You can't just use that one. You have to say that the one for the line we're trying to find is exactly the same. Okay, and going on to the equation, you can either use this equation, but the more popular one as you go through your schooling will be this one here. Y minus b equals m times x minus a, where a and b are your line. Okay, so y minus 4 equals the gradient, which is 4/3, x minus negative 2. So minus negative 2, let's just deal with that just now, plus 2. Okay. We can, at this point, multiply through by the fraction. Right, it might increase the complexity. We want to simplify it. Simplifying it means collecting like terms and writing it in its simplest form. Okay, so strategy here, multiplying each term by 3. Okay, treating that as one term because it's multiplying together. So 3y minus 12 is 4 multiplying x plus 2. Okay, further simplifying it, 4 multiplying x 4 multiplying 2. Further simplifying it again, let's get it into that general form, right? A general form, ax plus by plus c equals 0. Manipulating that, just making sure you're collecting like terms. Okay, so let's have this all over this side, okay? So we'll leave the 3y, we will minus our 4x, we will minus our 8, so minus 12, minus 8 is minus 20, and that's a suitable solution, okay? Might not be in this form, it's a suitable solution. If we wanted this form here, then we can do this. Okay, just reordering it. If you wanted that to be positive, you would multiply through by -1. Okay, so they are all suitable solutions or other strategies for finding the equation. Please watch the other videos to see how to do that, but each of them are exactly the same straight line or variations of that, okay? Okay, right, thanks for watching then.